Part 1 of our exam review, linear relations. Solve the following equations. Question A gives us 5x plus 20 equals 60. So with all these types of questions, our strategy is to get the variable on one side, on the left, and our numbers on the right-hand side. So 5x plus 20 equals 60. We'll keep the 5x on the left-hand side, and we'll bring the 20 to the other side. It becomes 5x equals 60 minus 20. 5x equals 40. If 5 times x equals 40, then x by itself equals 40 divided by 5. X equals 8. Question B. We'll gather all the variable terms on the left-hand side and the numbers on the right again. Collect our like terms. Will give us 11a on the left and 33 on the right. If 11 times a equals 33, then a by itself equals 33 divided by 11 for a final value of 3. Question C. We gather all of our x values on the left-hand side and our numbers on the right. Leaves us with negative 5x equals 10. X by itself equals 10 divided by negative 5. X equals negative 2. Question 2. Find the slope and y-intercept of the following lines. Well, since these are already in mx plus b form, it's very simple for us to figure out what the slope and y-intercept is. The slope is simply negative 2/3 for question A, and the value of b, or the y-intercept, is 1. For part B, m, or the slope, is 1/5, and the y-intercept is 3. Determine the slope, y-intercept, and equations of the following lines in each graph. Well, what we do is we look for coordinates that are on even parts of the grid, not halfway through, but actually fall right in the middle of a whole grid. So our y-intercept for this one is negative 2. So what we can do is we can count up a certain number of units, that'll be our rise, and then a certain number of units along the x-axis, and that'll be our run. So our rise for this graph is up 3 over 1. So our slope is 3 over 1, or 3. So we have a slope of 3. And we already know that our y-intercept is negative 2 because that's the point at which the line crosses the y-axis. Once we have those two pieces of information, we can simply say y equals 3x minus 2. In question B, we have a y-intercept of 1. Again, we take a look at our rise over our run. So in this case, our rise is down 1 and over 2. So our rise over run is negative 1 over 2, which gives us a slope of negative 1/2. We already know that our y-intercept is 1. We have enough information to spell out an equation y equals negative 1/2 x plus 1. Question 4. Solve the following system of equations by graphing using slope y-intercept method. So we're given an equation y equals x plus 5. And just from reading this y equals mx plus b form, we know that the slope will be 1 and the y-intercept will be 5. So we can start at the y-intercept And because the slope's 1, we'll rise by 1 and run along the x-axis by 1. Do that again, rise by 1, run by 1. Rise by 1, run by 1. And once we have 2 or 3 coordinates, then we have enough to accurately create a line through those coordinates. And there's our graph or line for y equals x plus 5. Our second equation, y equals negative 2x minus 4. We know that the y-intercept is going to be negative 4, so we can start there. And since our slope is negative 2, we'll go down by 2, over by 1. And we kind of run out of room on our graph here, so let's go the other way. And from this coordinate, we can also rise by negative 2 and go over by 1. So now we've got 3 coordinate points, which is enough for us to accurately draw a line through those 3 coordinates. And when we do that, we can see that the 2 lines intersect at the point negative 3, 2. So we say our solution of these 2 equations is negative 3, 2. 4b, solve the following system of equations by graphing using slope y-intercept method. So our first equation, 2/3 x plus 5. We know that our slope is 2/3, and we know that our y-intercept is 5. So if we start at the y-intercept of 5, our slope tells us that for every rise of 2, we run by 3. So starting at the y-intercept, we can go up 2, then across 3. Once again, we run out of room on our graph, so let's go the other direction. There's a run of 3 and a rise of negative 2. We have enough coordinates there to draw an accurate line running through those 3 coordinates. So there's our first graph. Our second equation, y equals negative 1/2 x minus 2. Our slope is negative 1/2. And our y-intercept is negative 2. So we can start at that y-intercept. Our slope tells us that we should go down by 1 and over by 2. So there's our rise of negative 1 and a run of 2. A rise of negative 1 and a run of 2. We have enough coordinates there to draw a line through those coordinates, and then we can see that the 2 lines or 2 graphs intersect at the point negative 6, 1. So we say that the solution to these 2 equations is negative 6, 1, or the point of intersection. Solve the following systems of linear equations by either substitution or elimination. Now for these 2 equations, we can see that both of them have the same coefficient for the y value. So it will be very easy to use elimination to get rid of these, to get rid of the y value. So we're going to use elimination, and we're going to subtract. So we got negative 2x minus 3x gives us 5x. Y minus y is 0, so we eliminate the y. Negative 5 subtract negative 10 gives us positive 5. And further solving for x, we get a value of negative 1. Once we have a value for x, we can substitute that back into one of the equations and solve for y. So we'll take that -1, we'll plug it back into the first equation and solve for y. -2 times -1 plus y equals -5. 2 plus y equals -5. Y equals -7. So our solution, or point of intersection, for these two equations will be -1, -7. Here we have another two equations. 4x minus 4y equals 4. 3x plus y equals 3. So let's try this one using substitution. Before we can use substitution, though, we have to express both the equations in a y equals mx plus b form. So taking that first equation, 4x minus 4y equals 4, we'll isolate the y on the left-hand side and the rest on the right-hand side, eventually giving us an equation of y equals x minus 1. We'll do the same with the second equation. We want it in y equals mx plus b form. 3x plus y equals 3. Y equals -3x plus 3. Now both equations are in y equals mx plus b form. Now in the first equation, we can say y equals x minus 1. The second equation, y equals -3x plus 3. If the right-hand side of both these equations equal y, then we can say the right-hand side of both of these equations are equal to one another. So we can write x minus 1 equals -3x plus 3. We bring all our x values over into the left and our numbers on the right, and we solve for x, ending up with a value of 1 for x. We take that value, that x value of 1, we plug it back into one of the equations and solve for y. So we can say 3 times 1 plus y equals 3, y equals 0. Our point of intersection, or the solution for these two equations, is therefore 1, 0. Question 6. The school council is trying to determine which banquet hall to hold the junior formal. The algebra ballroom charges a $60 per person cost plus an $800 flat fee. The geometry hall charges $55 per person plus a $1,000 flat fee. The cost C for dollars and N for number of people. So we want to write two equations, one that represents both scenarios, one for geometry hall and one for the algebra ballroom. So the algebra ballroom charges $60 per person, or $60 per number of people. So we could say that the cost equals 60N plus the $800 upfront fee. The geometry hall, their price scenario is $55 per person plus $1,000 upfront fee. So the cost for that is C equals 55N plus 1,000. We can set up a table of values for both of these equations. Fill in the values and then graph them. And when we do so, we can see that the two equations intersect at the point 40, 3200. What this means is that given 40 people, both of these halls would charge the same amount. So in a scenario where 40 people were attending both banquets, the price would be the same, the cost would be the same. And then we're asked, what would be the better deal? I believe it was for 600 people in this particular question. And in that case, the geometry hall would be the better deal. They start off with an initial cost that is higher, but as soon as we get past 40 people, the geometry hall becomes the better deal. The Yearbook Club is considering two different companies to print the yearbook. The Descartes Publishing Company charges $4.50 per book, plus a flat fee of $475. School Memories charges $4.25 per book, plus a flat fee of $550. The cost C dollars for number of yearbooks printed. So the equation representing the Descartes or Descartes, depending on how you're prone to pronounce it, is as follows. It is 4.5 n plus 475. Looks like I have a little typo there. M should be an N. School Memories charges $4.25 per person, plus an upfront cost of $550. So the Descartes Publishing Company charges more per yearbook, but a lower upfront cost. School Memories charges a cheaper rate per yearbook, but you have to pay more upfront. So we can set these two values. We're going to use substitution in this case. And we can set these two values equal to one another because both of these equal C. We can say they are equal to one another. So we'll say 4.5n plus 475 equals 4.25n plus 550. We'll gather all our variables on the left-hand side and our numbers on the right, and we end up with a value of 300 for n. Once we have that value for n, we can substitute it back into one of the equations and find out what the cost is for n number of yearbooks. So 4.5 times n, which is 300, plus 475 gives us a cost of 1825. So both of these companies would charge $1,825 to print 300 copies of the yearbook. If you were going to print more than 300 copies, then School Memories would be the more economical company to print the 600 yearbooks. Part 3, Quadratic Relations. Expand and simplify the following. X plus 3 times x plus 5. We use our FOIL method. First, outside, inside, last. And we For our second line for a, we end up with x squared plus 5x plus 3x plus 15. We gather our like terms, and we end up with x squared plus 8x plus 15. Part B, again, we FOIL these two together and end up with x squared minus 5x minus 6. And for C, we're given a situation where we have the brackets squared like this. My suggestion to you is that you write it out as two different equations. So we'll take that 2x minus 3. Sorry, I didn't state that quite well. We'll take that 2x minus 3 to the exponent 2, and we'll write it out simply as 2x minus 3 times 2x minus 3. Then we'll FOIL it. Our second line, or next line, will be 4x squared minus 6x plus 9, giving us a final value of 4x squared minus 12x plus 9. Common factor each of the following. So in questions like this, we want to find a number which will divide evenly into both terms. So we have 2x plus 6. What is a number that will divide evenly into both of those terms? Well, 2 is that number. So we can write a 2 bracket, and then we look and say 2x divided by the common factor. 2x divided by 2 equals x. 6 divided by 2 equals 3. So our common factor version would be 2 bracket x plus 3. For question B, it's a little trickier in that both of the terms have an x value. So we're looking for two numbers that will divide into 9 and 12, but we also have to take into account that we have an x squared and an x. So the number that would divide both into 9 and 12 would be 3. But we're not finished there. We can also divide x into both of these terms. So our common factor is 3x, bracket 3x minus 4. Question 10 gives us two examples of difference of squares. Sorry, just one example of difference of squares. You can spot a difference of squares when you can take the square root of both of the terms and they're separated by a negative sign. So we can take the square root of x squared, which is x. We can take the square root of 100, which is 10, and then we can just put a negative and a positive in each of the two brackets. 10b, we have to go about this a little bit differently. Here, we're looking for two numbers that multiply together to be 45 and add up together to be 4. We're going to treat them as positive numbers just to begin with, and then we'll deal with the negatives in a second. So we'll look at the factors of 45. They are 1 and 45, 3 and 15, 5 and 9, and so on. We don't have to go any further in this case, though. Okay, so we have 1 and 45. Now we can start to play around with the negatives and the positives and say, can we find a way of making 1 and 45 add up to be negative 4? The answer to that is no. Can we do anything with 3 and 15? by changing the negative signs or the positive signs to add up to -4? Again, the answer is no. But 5 and 9. 5 times 9 gives us positive 45 and adds up to something else, but 5 times -9 will multiply to give us -45 and -4. So we can use those two values. That's one way to try and come up with two numbers that multiply together to be -45 and add up together to be -4. Question C, we're looking for two numbers that will multiply together to be 16 and add together to be -10. One and 16 won't be any use to us. 2 and 8 can be, with a little modification. 2 times 8 multiplies together to be positive 16, but it doesn't add together to be -10. However, -2 and -8 do multiply together to be 16 and do add together to be -10. So the values that we would be looking for would be x minus 2, x minus 8. Question D, we're looking for two numbers that multiply together to be -10 and add together to be -3. 1 and 10 are not going to help us very much, but 2 and 5 will, again, with some slight modifications to the negative signs. Okay. -2 times -5 will multiply, they will not. Positive 2 and -5 will multiply together to be -10, and they will add together to be -3. Question E, we're looking for two numbers that multiply together to be 24 and add together to be 11. 1 and 24 won't help us. 2 and 12 won't help us. 3 and 8 will, however. 3 times 8 equals 24, and 3 plus 8 equals 11. So our answer is x plus 3, x plus 2. And question F, hopefully by this point you're able to recognize that this is a difference of squares. We can take the square root of x squared. We can take the square root of 49. And these two terms are separated by a subtraction sign. So we can say, using the difference of squares, x plus 7, x minus 7. In this question, we're given a graph and asked to find various features of this graph. So the vertex is 2, -5, right at the bottom. The axis of symmetry is a vertical line that always runs through the vertex. Its equation is x equals 2. The zeros, or the x-intercepts, the points at which the graph crosses the x-axis, are -3 and 7. We've got our happy face parabola there, telling us that the direction of opening is up. And the y-intercept, we kind of have to guess at this a little bit, just by looking at the graph and zooming in, but we could say that it's approximately negative 4.2. Calculate the first and second differences, if necessary, by completing the table. So this is the material that we're given, these two columns. So what we start by doing is we subtract this number from this number. So 3.75 minus 0 gives us 3.75. 5 minus 3.75 gives us 1.25. 3.75 subtract 5 gives us 1.25. And 0 subtract 3.75 gives us negative 3.75. So these first differences are all different. So that tells us right away that we don't have a linear equation. Now, to find out if we have a quadratic, we look over to the second differences. 1.25 minus 3.75 is negative 2.5. This subtract this is negative 2.5. This subtract this is negative 2.5. So the second differences are all the same. Because the first differences are different, but the second differences are all the same, we know that we have a quadratic equation. And our reasoning is first differences are different, second differences are the same. Use the Pythagorean theorem to find the unknown x. Round answers to one decimal place. Well, our Pythagorean theorem says that the hypotenuse squared is equal to a squared plus b squared. So in this triangle, we can say that x squared, which is the hypotenuse, equals 6 squared plus 4 squared. X squared equals 36 plus 16. X squared equals 42. If x squared equals, 52. X squared equals 52, then x equals the square root of 52. And the square root of 52 happens to be 7.2. So that tells us that the length of x is 7.2 centimeters. Here, we're given one side and we're given the hypotenuse. So the hypotenuse is h. So we can say that 10 squared equals 8 squared plus x squared. And then we'll solve for x. 100 equals 64 plus x squared. We can flip that around and say x squared equals 100 minus 64. X squared equals 36. Therefore, x equals the square root of 36, which gives us a value of 6 for x. So this length right here is 6 meters. Question 15, using the primary trig ratios. Find the missing side length rounded to one decimal place. Well, in question A, where our reference angle is 41 degrees. So we'll be looking for the sides relative to our reference angle. So once we know the reference angle, we can label our triangle with the adjacent, opposite, and hypotenuse. So we're told what the opposite is, 40 centimeters, and we're asked what is the hypotenuse. So the trig ratio that deals with opposites and hypotenuse is the sine. So we can say that sine of some angle equals opposite over hypotenuse. Specific to this triangle, we can say that the sine of 41 equals 40 over x. Sine 41 times x equals 40. Therefore, x will equal 40 divided by sine 41. At this point, you pull out your calculator and punch in the numbers to give you a value of 61 centimeters for x. In question B, our reference angle at the top is 60 degrees. Once we have our reference angle, we can label our triangle with the opposite, adjacent, and hypotenuse. Now in this question, we're given the hypotenuse and we're asked for the opposite. Once again, the trig ratio that deals with opposites and hypotenuse happens to be the sine trig ratio. So the sine of some angle equals opposite over hypotenuse. In this case, the sine of 60 equals x over 25. X will equal 25 times the sine of 60, at which point it becomes a calculator problem. And once we punch our numbers in, we arrive at a solution of 21.7 meters for x. Question 16. Here we're asked to find angles. So our reference angle is what we're trying to figure out. Once we have the reference angle, or know what the reference angle is, we can label our right angle triangle. So we are given the opposite and we are given the adjacent. So the trig ratio that deals with opposites and adjacents happens to be the tangent. So we can say the tangent of some angle is equal to the opposite over the adjacent. So the tan of theta equals the opposite over adjacent. So we'll say for this particular triangle, the tangent of theta, the angle we're trying to find, is equal to 20 over 13. Once we have tan theta equals 20 over 13, we can find out what theta is by itself by taking the inverse tan of 20 over 13. At this point, we'll plug in our values into our calculator and end up with an answer which will round to 57 degrees. Question B. Relative to theta, our reference angle, we are given the opposite and the hypotenuse and asked to find theta. The trig ratio that deals with opposites and hypotenuse is the sine. So we can say the sine of theta equals opposite over hypotenuse. Specific to this triangle, the sine of the angle we're trying to find equals 20 over 25. If the sine of theta equals 20 over 25, then theta by itself equals the inverse sine of 20 over 25. Again, at this point, we plug the numbers into our calculator and come up with a value of for theta of 53 degrees when rounded. Question 17. Use primary trig ratios to solve these problems. So we have a 2.6 meter long ramp that's running from the bed of the truck to the ground. So the ramp's 2.6 meters long, and the distance from where the ramp touches the ground and the truck is 2 meters. So we will rewrite this as a triangle just to make it a little bit clearer. So our hypotenuse is 2.6. Our theta, our angle, which we're trying to figure out, is on the bottom left. So using this reference angle, we can label our triangle. So we're given the adjacent and we're given the hypotenuse relative to the reference angle. The trig ratio that deals with adjacents and hypotenuse happens to be the cosine. So we can say the cosine of theta equals adjacent over hypotenuse. So the cosine of the angle that we're trying to find equals 2 over 2.6. We could therefore say theta by itself is the inverse cos of 2 over 2.6. Once we put these numbers into our calculator, we end up with an angle of 40 degrees when rounded off. So we can say that the angle from the ramp to the ground is a 40-degree angle. A ship is 565 meters away from a lighthouse. The angle between the line formed by the front of the ship to the top of the lighthouse and the water is 4 degrees. Calculate the height of the lighthouse above sea level, rounded to 1 decimal place. Assume the lighthouse makes a 90-degree angle with the water. So, redrawing that scenario as a triangle, there's our 4-degree angle, there's our distance of 565, and the x value which represents the height of the lighthouse. So, relative to the 4-degree reference angle, we can label our triangle. We're being asked to calculate the opposite, and we're given the adjacent. So the trig ratio that deals with opposites and adjacents is the tangent. So we can say that the tan of some angle equals the opposite over adjacent. In this case, the tan of 4 degrees equals the opposite, x, which we're trying to figure out, and the adjacent, 565. Tan 4 equals x over 565. Therefore, x by itself will equal 565 times tan 4, and our calculator will eventually tell us that that value is 39.5. Our therefore statement reads, the lighthouse is 39.5 meters high.